All right, everybody, welcome back to another Ask a Dev Unreal Engine live stream. My name is Kevin. We try to do these weekly. So far, we've been doing really well with that. The way this works is it's a live Unreal Engine tutorial. Usually the topics come from voting from our Patreon community, and we will kind of explore the things that you all are interested in learning. Let me just double check my audio levels. There we go. We're good to go. And sometimes, though, y'all's questions are so complicated, it takes a long time between, so I fill stuff in. So today we're going to be talking about materials. We're going to be taking a look at how to have our environment fade out a couple different ways for the case where our camera goes behind an object. Kick this around as an idea. Shadow, TJ, awesome to see you, PBL, Mr. Jeremiah, Matt, Off the Rails, Lax, you made it, you're awake, Matt, Brown Suede, good to see you. Skiva, and I can see you. A quick shout out, speaking of Patreon, you all are what makes this possible, allows me to keep doing this. So thank you very much for your support. Three of our three newest members, Richie, 1984, and Carl. Thank you so much. If you all want full credits, I'm happy to do that. I just try to be respectful of you all's privacy in those cases. And then as always, dude, our Discord's rocking. With so many people helping each other out, it's very difficult to give a shout out to everybody. But Greg C, Weird One, constantly out there helping people out. People, not afraid to ask questions, and we're gonna keep that. We're gonna work really hard to keep that a very healthy place to grow and learn in Unreal Engine. So with all the talky done, let's just go straight into it. I'll go through the tutorial. If you have questions along the way, hit me. If we have time at the end, I'll answer general questions and hopefully fill out the whole hour. We'll see. These always go fun, so we'll see how we do today. All right. So here we go. All right. First, basically all we have here, just so we're aware, for future us. This is Unreal Engine 5.4 right now. This is a third-person default project, and we've made no changes to anything yet so far. So what we're going to do is we need an object. I'm just going to drag this over here. I alt-drag that, by the way, and I'm going to scale this to represent one of those pillars in whatever game you're making, where when we approach it, if we go at this pillar, we get this camera thing that happens, right? Now, this is actually a collision setting where our camera is basically, as we're panning around our character, our camera is panning into our character and so on. This, for the couple of the games I've worked on lately, has not been the optimal. It can be jarring. It depends on what style you have. So what I want to do is I want this camera to pass through this object. So first things first. Now, generally speaking, what I would probably do is make a different collision channel or create a new object entirely that always does this. But what I need to do for the purpose of the demo is underneath, and you're not going to be able to see this because my head is in the way. Here we go. So these are our details underneath physics. If we go to collision presets, default, I'm going to go custom here. And what I want to do is I just want to check the camera to overlap only. All right, just that little change alone makes it so that as I come to this object now, my camera goes right through it. I don't have to worry about it. Now, this is what I want to be able to test out our material fade. Now, ultimately, we would probably make it so that all of the walls in the level do this, and we would either have to go through and tag it, or probably the easiest thing would be to make a new object that has that as a collision default property. So in order to do our fade, what we need to do is we need to be able to figure out what is between us and our character. That should be pretty straightforward because we have, if we look at our third person character, our blueprints, for some reason this opened up over here. You can see here in our viewport, we have our camera and we have our character, so we know where both of them are. There are going to be a couple ways we can figure that out. But before we do that, that's going to be the blueprint portion of what we're doing. Let's do the material stuff. So for the material stuff, let me redock this. Okay, for the material stuff, what I want to do is I want to take So this, under the level prototyping materials, there's this M prototype grid material. There's also all the material instances that come from that. So what I want to do, if we open this up, I just want to show you what we're looking at. The cool thing about this is, relatively speaking, this is a fairly simple material. All right, so what we've got is we have a base color and a roughness. That is it. And the roughness is nothing, it's just 1. It just means don't be shiny, okay? And then if you look at this, we have a background color, a subgrid color, a grid color, etc. And if you look down here, they're all color coded and pretty for us. So we can use this to do what we want to do. So we're going to be working in this material a lot today, but not this one. We're going to duplicate it. So let's take this and let's go to our tutorial map folder. I'm going to drag this over here and let's copy it. And then let's rename this. This is going to be our M underscore ENB grid fade. Shrooblord. Very cool. I'm glad this might help you out. Okay, so here we go. First things first. If you watched our Fog of War tutorial, or probably any of our other materials, hopefully by now you are at least familiar with the idea of transparency and masking, okay? So if we use a mask, it means that we can make the material go not transparent, but we're literally masking it, 0 or 1. That would work, and there are ways to do it with masking. Sure, actually, let's just do it with masking first. Okay, we need either masked or translucent for this to work. So we're gonna start with masked, okay? The reason I'm saying that is if we take this material and we take a radial gradient, exponential, and we pop it into our mask, okay, you can see our material is now masked, right? Now, if we apply this, and we assign this material to our box in our level, I'm gonna drag this up here so y'all can see it again. We can just click on that, assign it here. So our material is updated. All right, now if we look at it, you'll notice that our object is masked, okay? This isn't quite how we want this to work when we walk around it. Wouldn't it be cool? You know what, I'm gonna change the order here. Let's just go transparent first. Because I wanna show you a couple things. If we switch this, let's switch this to transparent. Remember, translucent means that it has fade off. So if we do that and we connect that to the opacity, that's gonna work. We can apply that. We'll come back to mask, don't worry y'all. Okay, so you can see we have this area where it's semi kind of transparent. So technically right now, we can see through it, right? And that's kind of what we want. We wanna be able to see through this whenever we go through that. All right, so all we're going to do is we're basically going to drive this opacity in world space based on a couple things. But before we even get to that, right now this is kind of looks bad in my opinion, right? Because we're not really controlling where this transparency is happening. So we would actually probably need to mask that using a sphere mask. So once again, I'm going to switch gears on y'all, and we're going to go back to making it so that it looks wireframe instead. So imagine that you just watched all of that and you're confused as hell. All right, reset. We're going to make this thing look wireframe. Starting again. All right, let's switch this back to masked. I apologize, y'all. Okay, so what I want to do is I want to make it so that as we look through it, we can see it like wireframe. The cool thing about making a wireframe is we have all this grid stuff right here. It's all done for us. So if we take all of this, okay, and we copy it, all right, all this is, if we right click and preview this, you can see that this is going to be a background color. This is going to be alert. If we start previewing it, you can see it's kind of white looking. Then we can preview the next one, and you can see this gives us our darker lines. And if we feed this into our opacity mask, what we get is we don't have any opacity yet. And the reason being is because we have black lines and white lines that all have values. So we need to replace this background color. And what I'm going to replace the background color with is a vector 3. So I'm going to hold the 3 key and left click, and that's going to give me that vector 3. And then if I take this and I change this to white, okay, so we have that, and we need to stop previewing. Okay, so we basically have the inverse of what we're looking for, right? So you can see, we can see through our lines, but we can't see through our material. If we were to change this back to black, just so you can see, and we click OK, the whole thing's invisible. So that's not what we want. So what we need the white. We can see our lines, but we need to invert this whole thing. So here's what I'm going to do. I'm going to take this output and invert it by going 1 minus. So what that's going to do is, if the pixel is, in this case, see-through, or it's easier to do black and white. If the pixel is white, that's a value of 1. If we say 1 minus 1, that's what? 0. If the pixel is black, what we have is 1 minus 0, because black is 0, and we get 1. So this basically inverts it as long as you're going from 0 to 1. So when we plug this in, you can see now what we have is we have a grid, which is pretty cool. All right, and if we look at this, you can see what that does is that turns our tower into a grid. Okay, so this works as far as, this is visually what I want for the masked version of it. I want it so that when we pass between this object, it will show up, and you can see basically this wireframe, and I can still see my character, so it doesn't mess with gameplay. I do want to check to see what this looks like if we turn on. Nah, it's not too much. It's cool because we can see the other side now too. So I did turn on two-sided, and what that means is it's going to draw materials on the inside and the outside of the object. Usually you use single-sided to save calculations, etc., but this will work just fine. All right, so this is what we want. Now all we need to do is get it to turn on and off when our character walks by this object. You with me? I have not looked at the overdraw on this, but we're going to talk in the end a little bit about ways to make this more efficient. So, okay, so now what we need to do is we need the ability to fade this out. So, or control, okay, wait, that's me. That's me, okay. So what I want is, I am going to, let's take a look. Okay, we don't need this. We want to make sure we're working in the right material. All right, so we have our material, okay? And what we've got is we've got our 1 minus. Now what I want to do is I want to do one more thing. If I change this color to black, I believe. Yes, we get solid. Okay, so in order to control the fade, all I need to do is change this from black to white. That's the general gist of it. So for now, let's change this back to white. Okay, and then I'm going to put in a multiply in here. And I'm going to multiply it by 0, because why? 0 represents black. And so effectively, that's going to turn it to black. However, what I want to do is I want to be able to sometimes multiply by 1 and sometimes multiply by 0. So when I multiply by 1 is when the object has detected a collision between the camera and the character. All right, and what I'm going to do is I'm going to create an auto fading material kind of setup here. So let's create a variable. This is a single value. I brought this up by pressing 1 and left clicking. I'm going to right click this and convert it to a parameter called start time. This is very similar to the type of stuff that we did with the fog of war fades. All right. And then what we're going to do is we are going to subtract off. Well, actually we do need to add. So we're going to take our start time, and then we have to decide how long the fade back is going to last. In this case, let's start with a second, and I think we're going to change it. So our start time plus 1 second, and we're going to subtract the game time. So let's get the time. So this is our current time in our game. So here's what happens. At 10 seconds, I start this fade. What's 10 plus 1? 11. What is 11 minus 10? Because remember, the time right now is 10 seconds. What is 11 minus 10? It's 1. 1 times all of this will be 1. Okay, now let's go to 12 seconds. All right, the time is 12 seconds. Our start time was 10. 10 plus 1 is 11. What is 11 minus 12? It's -1. So effectively, that would be 0. So we would either need to clamp this to be 0 to 1, for example, or what we're actually going to do, actually let's start with the clamp and then we'll come back and do the remap. Let's just make sure the clamp works. So we're going to clamp this to be 0 to 1 so that this will fade in. Now theoretically, what this should do is this should make it so that once we get our overlap working, at least it will turn on and off. It's not going to fade because there is no fade on this. This is a masked material, and once you cross 0.5, it's all on. You would have to do all kinds of the erosion and everything like that, which is why we're going to switch to transparency here in a second, just so you can see it working. All right, so in order to get this to work, to demonstrate it, what we need to do is we need to do a little bit of our detection inside of our character. So in our event graph, I am going to add an event, a new event for event tick. So let's go tick. Cool. Now, this is where it gets kind of fun. All right, we have our camera position. Okay, so let's get the location of that. Get the location of that. Get the world location. Okay, and we also have our mesh. You know what? Let's get a socket position. Let's get a socket location in world space. Socket location for the mesh. And the one I'm going to use is head. Just that seems reasonable. We could use chest, you could use head, whatever you want. Okay, now what we want to do is we want to detect if there's anything between these two objects. So there's a couple different ways to do that. The first way we're going to do that is we're going to do a line trace. So let's do a line trace. So we're going to do line trace by channel. Our starting point is going to be our camera. Our ending point is going to be our character. Okay, now the way this works is if it hits something, we'll get a result here. So all we're going to do is if we break this, meaning take a look at all of the stuff we get, one of the things that we can get is this hit actor. I want to know if this hit actor is a static mesh. Okay, so let's cast this to a static mesh actor. So all this does, if you're not familiar with casting or inheritance is confusing to you, it's okay. Super confusing for me at first. There's a whole tutorial on that, on blueprint inheritance. That's the one you're looking for. I'll put a link into it when I go back to edit the video. But basically all this is this thing that hit, can it be a static mesh actor? And if it can, now I can do all the things I can do with static mesh actors, like get the materials. So let's get the material. There's only one on this, so I'm not going to do the whole for loop thing in today's tutorial. So we'll get the material. But you would need to get all the materials if you want this to be super robust. Okay, now, why? Okay, let's take a step back here for a second. Why am I getting the materials? I'm getting the materials because I want to be able to set this parameter, start time, so that the minute there's an overlap, I'm going to say, hey, start now. And then this is effectively going to kick off a timer that's going to start counting down. And if there is no overlap, after 1 second, it will turn back to fully solid. Okay, so back to here, that's why we're getting our materials. However, we have a problem, and that is that Unreal and its efficiency, there is a difference between a material and a material instance dynamic. And the dynamic materials are intended and created so that those are things that actually have values that change at runtime. However, by default, all of these materials are not dynamic. They're static, if you will. Okay, so we need to actually convert this to a dynamic material, but we don't want to do it every time. So we have to do a little bit of logic here. So let's cast this to a dynamic, material instance dynamic. All right, here's what we're going to do. Okay, if it succeeds, that means it's already a material instance dynamic, and we can just go ahead and with our material instance, we can set our scalar parameter value, and that scalar parameter value is our start time. Start. Let me zoom in so you all can see this. That's our start. I can't even spell. Start time. Okay, and the start time is, let's get current game time in seconds. Nope. Time in seconds. Let's try that. Time in seconds. Get game time in seconds. That's the one I want. Okay. So if it's already a static, a material instance dynamic, just do the thing. Cool. If it's not, we need to do a little bit more work. So if it's not, what I want to do is I want to create a material instance dynamic. Okay. Now that we've created it, we need to assign it. Okay. And so the target for this is going to be this static mesh component, and the element index is going to be 0. I'm assuming there's only one material. If you have a much more complex environment, your collisions, etc., have multiple materials on this, you would need to do this with a for loop. You would need to update each one, etc., and we'll have a conversation at the end about some of the efficiency concerns about this. Okay, so we're going to create a material instance dynamic, and once we have that done, we can go ahead and set this. Now, why is this cool? So, we need to connect this in. All right, so if the first time we overlap an object, the material on the object is not a dynamic material instance, then create one and assign it to the object. Now, the second time we overlap that object, it will be a material instance dynamic, okay? So it's just going to set the value. It's not going to keep recreating new ones. Now that we have that, theoretically, this should work as far as our overlap is concerned, and we just need to check to see how it goes. All right, so I believe we might, well, we have something. We have something. Okay, so let's check a couple things. So first off, are we getting to here? So there's two ways we can check. We could do a print string. Let's do a print string here. Hello, and let's do another print string here. And this is going to be new. All right, so hello. Interesting. Oh, okay, yeah, that makes sense. So it is a material instance dynamic. It is getting there. It is setting the value. That's cool. Okay, so now we just need to see what's going on with our material logic. That looks like it's busted. So let's connect this in. Cool. Start time, did we spell? Oh, you know what it was? I think. Let's see if it was something simple. All right, we didn't apply these changes. With materials, if you don't apply the changes, it doesn't actually work. So let's apply and save. Let's just save all for good measure. And yeah, I think we're closer. So we're gonna go over this. Look at that. Okay. So now when we do that, and you can see it fades back. After 1 second, it pops back. Cool. So we've already started getting our fade and stuff working, which is cool. All right. Now I'm gonna change this. I don't want shadows on this thing. It's gonna just drive me nuts. Shadow. I'm gonna cast shadows. Okay, cool. So cool, our fade works. So now before I get into actually like changing this to translucent, etc., does anybody have any questions? Okay, let me catch up in questions here real quick. If you have a multi-material mesh, you need to implement those changes on all your materials. What I would do is I would make a base material shadow, TJ, and then do all the inheritance and stuff. Also potentially make a material function that you can just plug in. There is a little bit of juggling you have to do with this. Yeah, so Lax is on this. See, I don't even need to be here. We got everybody answering everybody's questions. Okay, so is the audio still out of sync, and should we try a reset again? Okay. Let's do the risk. We'll risk it. I will be back, y'all. Okay, are we back? Okay, so we made it back. Now the question is, are we in sync? Okay, cool. Sorry we missed that earlier. I don't know why it does that to us. Okay, so it looks like we're all cut up. Looks like we're back in sync. Now let's just make a couple switches to make this look better so you can kind of see the effect actually working the way it's intended to. Right now, we are currently, as I mentioned, we're connected to the opacity mask. Remember, a mask is 0 or 1. It's on or off. The closest you can get to making this look like a fade is to erode out the material. So we're actually going to switch this to a full opaque material. So, a translucent material. So I'm going to switch this now to be translucent. Okay, and I'm going to save and apply. Now we may run into some problems with our transparency sorting when we do this. We did. So this is there's a transparency sorting thing here. And I think there's a couple ways to potentially take a look at this. What we could do, for example, is we could just simply take this and not make it two-sided anymore. All right, and we'll just apply that change. So now it's not trying to fight with itself. So here we go. You saw it fade on. Okay, that was just because when we started. If we overlap it, okay, that still works exactly the same. And that's cool because from a player standpoint, I don't want it to fade on. I need to see right away when my camera crosses it. Now the question is, when we leave, does it fade out? It does. So that's cool. Now, it's a little too slow, right? This is too slow for us to, like, it's kind of weird that the environment, we want it to feel natural. So that's where we start getting into how are we going to control this. So let's go, let me just save this. Okay, so remember what I said. This is how long the fade lasts. This is the fade duration, this 1 second. All right, now the problem is if we change this, actually, you know, that's a really good question. So John's like, what's the performance impact? So let's do a couple things. Let's go stat FPS. Okay, so first off, we got our frame rate. It's roughly 90-ish. Still 90-ish, it looks like. If we look at our overdraw, or our complexity, we got a little bit of red because that's a material, right? But that's when we're doing it with the transparency. If we switch this back to masked like we were before, so if we go back to masked just for testing, if we go back to our overall, we're green, 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 we can see through it green the whole way. So it is the exact same thing as when we were doing fog of war stuff and everything like that. You got to understand transparency cost, and you're going to have to weigh in your target platform, your target audience, all those things. How important is it for your camera, your material fades to potentially be like super sweet looking or what? So for me, I got 90. I'm still getting 90. I'm not worried about it. It's cool. Okay, now let's go back to what we were doing. Okay, so we were translucent, and I was going to explain, but that was a really good question. Okay, so here we are. We have a 1 second fade. This is our start time. So I'm going to promote this to a variable right now. Promote to a parameter, sorry. This is going to be our fade time. Fade time, nighttime, daytime. Okay, now however, our fade time default right now is 1. Okay, the problem is this clamp is no longer going to work. And what do I mean by that? Let's say we want our fade to happen faster. So let's take our fade time and make it 0.2. When we do that, our start time only ever gets to 0.2. So we're going to only get to 0.8. We're never going to get to 0 to 1. So our material is never either, it's either never going to be fully transparent, or it's never going to fade fully back. In this case, it never gets fully transparent. But you'll notice that my fade out time is 0.2 seconds now, which is cool, right? So the problem is we need to remap all of this stuff. We can't just clamp it. We need to actually do some trickery over here. And what we're going to do is we're going to take the result of this subtract and we're going to remap it. Let's try this. So we're going to remap a value ranged. And last time I did, by the way, when I did that, when I've done this before, sometimes in this material, all of this got disconnected. I have no idea why, but it happened every time. I restarted Unreal, came back, it worked. All right. So now what are we remapping? We are going to remap our low value is going to be, I pressed 1 and left click so I could get a single variable. So our input low is going to be 0. Our target low is also going to be 0. Okay, but our input high, this is the one that we want to be our fade time. So in this case, we can go from 0 to 0.2 now. And what we want to do is we want to take 0 to 0.2 and remap it to be 0 to 1. Or if our fade time is 0.5, 0 to 0.5, remap it to be 0 to 1. That way, whatever comes out will get us to a fully faded material. You with me? So let's go ahead and one more single variable. This is a 1, we said, is where we want to go to. We're going to plug this to our target high. We should not have to clamp anymore. We should not need that anymore because this is going to automatically do it for us. This should plug it in. Famous last words, of course. Apply and save. And now when we go and we overlap, first off, we are fully transparent, which is cool. And when we come off of it, it fades out. I think a 0.2 fade time feels much better personally. Like it's not distracting to me. Okay? So that is generally speaking all of the moving pieces to how this works. However, we're going to do this another way. We're not done. Okay? So what we're going to do is we're going to do this with an alternate method using sphere masks. But I'm going to keep this in here just so that it's here, because a bunch of this stuff is going to be exactly the same. In fact, we could probably take, let's see here, how do I want to do this? Yeah, let's just take all of this and comment it. And we're going to call this, and actually I meant to remove this. There we go. So let's take all of this and let's comment this. And let's call this the wireframe method. Okay. Now, the wireframe method works because in a prototype environment, this is great for prototyping, right? You have that grid material, you're using the grid to figure out how to lay out your level, all that stuff. But then you start dropping in all your white box stuff that maybe actually has textures and so on. In that case, you're going to have to potentially take the actual base material, plug it all in, all those kind of things, and or replace it completely, etc. Or we could just cut a hole in it. What if we just cut a transparent hole in it? So let's just do the whole method. So I'm going to keep this the same. This is basically our material fade timing. We'll paste this down here. Now what we're going to do though is we're going to use, in this case, we're going to use a sphere mask. Okay, so we used sphere masks during our Fog of War stuff. So if you watch those, this will be familiar. But basically what this is the easiest way to think about this is it creates a sphere in space somewhere. And the somewhere is the B. That's this B value, okay? That's where the sphere is. The radius of the sphere should be clear. And the hardness, let's go hardness of, yeah, we'll keep hardness at 100 for now. And then, so the B is where it is. So let's actually plug that in. Let's do a vector 3. We're going to call this the location. What time is it? How are we doing for time? Okay, so we're going to call this the location. So right now, what is the value of black? 0, 0, 0. So right now, the sphere is being checked at a position of 0, 0, 0, right? Just because it's RGB doesn't mean it doesn't have 3 values and we can't use it for position as well. So that's really what's kind of a mind bender about the material domain. The material domain has a fourth dimension, not just what you think of as a canvas that you paint on. No, there's time, there's like 5 dimensions. You have the canvas you're painting on, what it looks like, the pretty colors and all that stuff, but then you also have where that material is in space and in time. It's kind of wild. But anyways, so this sphere is at a location of location. In this case right now it's at 0, 0, 0. Okay, and then what is this going to check? It is going to check every pixel in a certain radius. Well, which pixels is it going to check based on? We're going to use the absolute world position of the pixel. Absolute, no, let's try world position. Let's just type position. Position. World position. So what this is saying is we're going to get the XYZ position of every pixel, and we're going to check to see it versus this location and within this radius and this hardness to determine whether or not there's a mask or not here. Okay? Now, if we take this, all right, and we plug this straight in, let's see here, we need to go, we do need a 1 minus because I want to flip this. All right, and then what we're going to do is, this one we're going to do a little bit differently because, let me see if I can show you. Well, let's just get the mask working. Let's get the sphere mask in place, and then I'll show you the problems we have down here. So we're going to take this, and we're going to plug this into our opacity. Okay, now in this view, let's see here, we have location 256. Let's drop this down to 128 so we can see it, because 256 is going to be pretty big. And then if we apply this, and we look at our level, let's see here. Oh. Okay, why don't we see anything? We don't see anything because this object is not at 0, 0, 0. Where's our location right now? Our location is over here at 0, 0, 0. So theoretically, yeah, you can see it now. If we move this object down here, you can kind of see the sphere, right? You can see like there's this, it's almost like a sphere cutout. So there's a couple things that we need to do to get this working for your brains to wrap around this. Just know that this is masking out anything that is not inside of this sphere. So we're going to actually need to do, like, change the logic slightly about how this works. All right, but just know that it's at this order. So one of the things we need to do is we also need, in addition to, hold on, let me get this back in a reasonable place. Okay, I want this to sit straight on the ground, y'all. There's a shortcut. I'm just press the end key and it will drop straight to the ground. It will automatically place it on the ground for me. Okay? All right. Oops, I messed it up. Okay, so end key and it'll drop it down. Maybe not. Messed it up. Oh, now I can't even see it. Oh, Unreal is messing with me today, y'all. Okay, cool. So what we need to do is we need to go back to our third person character, and when we are updating these parameters, we need a couple other parameters. Okay, so that parameter that we need to set, remember we called it location. We need to set this location. So in our third person character with this material, what we're going to do is we're going to, in addition to setting the start time, we're going to set a vector parameter value. And in this case, the value that we're going to set it to is where. We want it to be where the hit was detected, which is this location. Okay, so let's plug that in here. Okay, and we're going to do the same thing down here. We're going to set this. Okay, and then once again we can probably take this from here. This is our location, plug it in. All right, and we do need to name this. If we don't, this isn't gonna work. So let's go location, 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 location. Cool. All right, so now we've set both of those parameters so that works. And when we overlap, you'll see the overlap is working, but it's the opposite of what we want. Okay, so here's what we're gonna do. We're gonna switch this a little bit. In our material, rather than using multiplies, etc. What I want is, I want this mask to be, first off, we need to invert it. So let's go 1 minus. Okay. And then what that's going to do is this. I'll show you the problem. Okay, if we apply that and we press play. So we've just inverted the thing. So now all we're doing, oh, I actually have 2. Wait, did I create another box? I did. That's why it looked weird. Okay. So now we have our thing, and we have our kind of our sphere cut out. Right? However, I want to show you something. When, like, this looks like it's working, right? Wrong. I mean mostly right, But if I walk away, look, it left a chunk. It leaves a chunk cut out of my environment piece. I don't want that. So why is this happening? It's happening because, remember, as the camera and the character were overlapping and it was doing that trace and it found a spot, when the overlap stopped, where was the last position of the sphere? The last position of the sphere was right here on the edge. So it just leaves it there. It leaves it there until the next time I do an overlap, and then it will just leave it there. So we need a way to either tell this thing that when you're done overlapping, fade out completely and stop the effect, or shrink the effect, or any number of things. So in this particular case, what we're going to do is we're going to use a lerp. Okay, we could, in my experience, we could use this fade to multiply by a radius so that it would actually shrink. But in practice, what I found was a shrinking radius looks weird from a player perspective. But you can try it like that if you want. But rather than doing that, what I'm going to do is I'm going to create a lerp here. Linear interpolate. Hold on, let me double check how we're doing questions. Okay. Holy smokes, I'm going to need to do some catching up in the questions. Okay, thanks. Super familiar with you. Okay, cool. No real question. All right, so what we're going to do is we're going to linear interpolate. We're going to linearly interpolate between our sphere mask and just solid. Okay, so what we're going to do is we're going to create a solid white. Why white? Because white's value is 1, which means it is completely opaque. Okay, so we'll feed this into our B channel. And then what we'll do is we will feed this is all of our timing stuff, into the alpha. So when we come in, if our start time is 10, and we go through the exercise again, when 10, let's say our start time is 10, which is 11 minus 10, 11 minus 10 is 1, 1 faded, etc. is 0, so our alpha on this is going to favor the sphere mask. And then as we get further in time, it's going to fade out the other way. So what we can do is I'm going to control drag. This is how I move it without having to pan. I'm going to control drag this in and connect this in. Okay, apply and save. And then when we play, now when we overlap, the overlap still works, and you'll see that it fades out now, right? That's what we want. Okay, now you could potentially make it faster, etc. But now we have that working. Now you can see that's what it would look like if it was even masked, because right now our hardness on our sphere mask is set to 100. Let's try 20. I actually think this looks much better at 20, or some lower number. Okay, so let's go to our map, and when we overlap this, I think that looks pretty good, right? We can very nicely see our character. It fades out nicely. We're good to go. Now this thing is not on the ground. Now it's on the ground. Cool. So from a player standpoint, I feel like as I'm running by this, that feels good. You're just going to have to figure out what feels good for you. Now, we still have the problem on this wall. So what does this look like in this wall? Well, look, all we have to do is apply our material. This is our material. These are the details for this wall. We can just apply this material to the wall. Under physics, we do the same thing. This is why ultimately you would probably either set up a blueprint or something a custom collision channel, etc. In this case, I'm going to go custom, and I'm just going to ignore camera. I think in the past on different projects, we had a different collision preset, which was like environment, ignore camera, or overlap camera only, or something like that. And that worked really well. So now we know it works over here. Looks good, right? Fades out, doesn't mess with my gameplay. Same thing here. Now, whether or not you feel like this should be a larger circle, you know, when you're far away, but at least I can still fight when I'm out here. And you'll notice that when we get here, we're back to this thing for me whenever I play games personally, and I get to this where I'm running into the wall and the camera's doing weird things. I don't know. I thought this was cool. I thought it was a great example of blueprints and materials and all kinds of fun stuff. Now, there's a couple of things that are worth talking about. So one we already talked about, which is the performance. Okay, so with that performance, there is, you know, we talked about the difference between using translucent versus masked. There are versions of this that worked with masked. There is also the version of this where what you do is you basically just swap in a separate material, for example. But the other one that is worth talking about, that for some reason our community is super astute on the performance aspect of all this, and right now we're doing this on tick. And how expensive is it? Well, hold on a second, let's see. Right now we are running at 12 milliseconds, 12, 13, 12, 80, 90 frames per second. Okay, great. If we remove our tick completely, compile and play, we are 12, 80, 90. It's still the same. Like, that's not doing anything for me. However, if you're trying to find every little tick, okay, let's play the game. Let's find every little tick. How might we be able to do this if we didn't want to use tick? And by the way, this was not part of what I thought I was going to be talking about. What actually, yeah, you would probably disable it in runtime. But what I was thinking was, what you could do is you could add a collision here. Let's do a capsule. I have not actually tried this, but I thought it would be cool to try. If we take the capsule and we parent it to the camera, okay, and then we zero it out. Interesting, that's not actually following the camera, is it? There we go. It's got to be on the boom, I guess. Okay, that's fine. So now if we rotate this 90, we can zero these, I believe. Cool. And now let's do this. Let's just drag this out here, and then let's change our capsule half height. I don't know why drag's not working. Let's try 200. 220? Sure. Now we need to go far enough that we're getting to our character and beyond the camera lens. This is my theory. I haven't even tried this, so this is where everything always gets dangerous in these live tutorials, when I come up with some crazy idea. Okay, so what's going to happen here is, the idea here is when our capsule overlaps, we will trigger this event, rather than doing it on tick. Andrew, you're welcome. And thanks for chiming in. Lax, have a great day, night, whatever time of day it is. All right, so we've got that. Our capsule's here. Now we need a new event. So for our capsule, if we right click on it, add an event on component. Interesting. This may not work. I like the idea, but this may not work. So on begin overlap, we're going to do our line trace. And then what we're going to need to do is, as long as we're overlapping, we're going to want, let's see, what else do we have from an overlap standpoint? On component hit, cursor over. I thought there was a component is overlap. Oh well, we got an end overlap. I don't know if we need the end overlap, but let's just see if we can get it to work one time. So if the capsule overlaps, then what we're going to do is we're going to do this. And we don't even need to do the line trace, but I'm going to keep the line trace for now so I don't have to change all my logic. Let's see here. So either we're not overlapping. Let's try, let's see if we're overlapping. Oh, I see. It's always overlapping. Okay, hold on. Let's make this a little bit shorter so it's not actually capsule half height. This may be a bad experiment, y'all. Let's try. Uh-oh. Oh no, crashed. Okay, unfortunately, that may be the end of the tutorial. Did not like that. Okay, basically the theory is, so the theory is this. Rather than doing this on tick, what you would do is when that capsule detects an overlap, then you trigger this state. And what you could do at that point is you could set a variable that either allows your tick to do its work, or you could kick off a timer by event or something like that, so that rather than ticking all the time, you're only ticking while there's an overlap in place. So in addition to using masked versus translucent and using, so that's one efficiency potential talking point. And then the other one is, you know, not ticking all the time. That would be, for example, another way to do it for ticking all the time. In general though, as you saw from a performance standpoint, I mean, it wasn't there were probably many other things that were higher performance than that single line trace that I was running. So we are going to, and that also means that I couldn't save the project for Patreon. All right, I will redo the project for all of our Patreon members so that I can post up that material for you all. So for everybody else, does anybody have any questions while we're still here? Let me just run back through. Let me run back through the chat and see if I missed anything. I don't think so. I think we got it all. All right, y'all. So, as always, thanks for supporting the channel. Thanks for being the best part of this. Appreciate you being part of this. Patreon, what do you support with Patreon? Well, there's different tiers. Some of them are early access to videos. Some of them are access to project files. Some of them is one-on-one coaching. It just depends. So, but as I was saying, thank you all for helping push me to learn all this stuff. I very much appreciate it. We'll probably be doing another Patreon dev stream coming up here today or tomorrow, just as a general heads up for all our Patreon members and everybody else. Don't forget, in addition to the live, I know you know the live, but a lot of times people don't realize we have both pre-recorded and live videos. So make sure you check those out. As always, keep the feedback coming. There's no point in doing this if you all don't find it useful. So let me know. I hope everybody has an amazing rest of your week. See you on the next one. Take it easy.